Example 2 addresses a cantilever beam. Okay, its cross section is a circle, and the diameter of the cantilever is 5 inch. It supports a concentrated load P at the free end. So the length of the cantilever beam is L equals 2.5 feet. So determine the magnitude of the maximum shear stress in the shaft and the maximum tensile bending stress in the shaft. Okay, so it's requesting you to calculate the maximum shear stress and the bending stress, which is one shear, one normal. Okay, we just need to use two equations to find these two maximum values. It's a very straightforward calculation. So first of all, let's look at the maximum shear stress, right? Tau max. The equation is simple, as we just derived, it equals VQ over IT. Right? So the I is obviously a global constant, and T is also a constant. So is V constant? It depends, right? Depends on the loading, where we need to do free body diagram and to derive the reaction forces, then draw the V diagram. Then you find the global maximum value of the V. Right? But anyway, we need a maximum V value and we need a Q max. Okay, we need to find the two maximum values. Okay, to find the V max, we need to do some analysis. Right, let's redraw this cantilever in the opposite direction. Okay, you add a load P equals 850 pounds to it. Then I believe everyone knows how to do this free body diagram and find out the reaction forces, right? Let's consider here is AY and MA. And you can easily find the two values. I will skip the steps, then we can directly give you the V diagram and M diagram. Okay, the V diagram will be simple, right? It's the constant. The constant of 850, and the bending moment diagram, it will have a value, the MA equals PL, right? You have the maximum value at the fixed end. The value is P by L, and then it turns to 0 to the free end. Then okay, here's the V diagram and M diagram. Okay, you can see that the V is a constant, so our V max will be just 850 pounds. And the Q max, okay, we have an equation. If you forgot the equation, go back to the previous slides to find it out. Right, it's 1 over 12 D cube. Right, the D is 5 inch, so you get a 5 cube over 12. So that is 10.42 cubic inch. Right, the I is a global constant, and for a circle is pi over 64, D to the fourth. Right, the result will be 30.68 inch to the fourth. Then what is the T? Right, T is a constant. So T for a circle, the T equals D. Right? This is important. Keep this in mind. So it will be 5 inch. So the tau max can be calculated as V max by Q max over I by T, right? So here you will get 57.7 psi. Then we're done with the tau max. Then we'll find the sigma x, sigma max, the maximum bending stress. Okay, the equation is my over I. Right? I is a global constant, no question. But how about m? Right? M has a maximum value, so we need to find it out. And y has a maximum value, we need to find it out. Okay, so as we just analyzed, the maximum bending moment is right here, equals P by L. Right? So the maximum bending moment can be calculated as P by L, and the L is 2.5 feet. Right? 2.5 feet. You need to turn it to inch by another 12. And here, Y max obviously is half D, right? 5 over 2 over I. The I is 30.68. So here you will get a very big number, and compared to the tau max, right? It's 278 psi. Okay. Calculations are simple, and it's easy. It's very straightforward. So you can get the tau max and the sigma max. Okay. Please compare these two values and tell me what conclusions you can reach.